Welcome to my channel. When you first commence woodworking, it won't be very long before you discover the mortise and tenon joint, because it is the primary joint used to join timber at right angles, and therefore it is superior to all other ways of joining timber that way. You can use other methods such as biscuit joinery or pocket joinery, but they are inferior to the mortise and tenon joint. In this particular video I'll show you how I cut the tenon, which is the male part of the joint, using a table saw. I designed and made a crosscut sled that I use for this purpose, and in a future video I'll show you how I make that crosscut sled. On the screen now you can see a typical mortise and tenon joint. That's the tenon and that's the mortise. And in this video I'll show you how the tenon, which I'm pointing at now, is made on the table saw. Done correctly, they neatly fit together. Form a very strong joint when glued. Before we can cut a tenon, we have to know what size it has to be, and this is calculated from the mortise into which it has to fit. I use a digital vernier to measure the width and the length of a mortise. In this case I've measured it to be 20 wide, and I measure the width of the timber that I'm going to cut the tenon from, and you subtract the two, divide by 2, and that gives you the depth of cut that you have to set up the saw blade for to cut the sides of the tenon. The depth of the mortise needs to be known as well, and I again use a vernier to calculate that. The tenon will be slightly less than the depth of the mortise. I usually work on about 1 millimetre. No strength is lost because the end of a tenon is end grain, and end grain does not give you any strength when glued. To determine the size of the tenon in length, the same process is followed. You measure the length of the mortise, then the width of the timber from which the tenon is going to be cut, subtract the 2, divide by 2, and that's the depth of cut that has to be made to make that right size. The next thing we have to do is to set the depth of the saw blade, and I do this by aligning the sled to a centre point marked on the top of the table saw. It's a scribed line in the metal, but I've highlighted it with red. There's also a similar mark on the red mark on the end of the sled, and that will position the saw exactly in the centre of the table, with that line showing that centre mark. Now, with the table in position, I can now measure the depth of cut using a vernier. It's usually just a little bit less than half the total depth. In this case it's 5 mil less a little bit, which is about 4.7 mil. I'll now give a brief description of this sled and how it works. What you see is a block with a 10 mil threaded rod that's adjustable, and that gives the actual size of the tenon, the length of the tenon. When the block is put against it, it'll give the correct size of the tenon. Before cutting the tenons, I check with a scrap piece of timber that all my settings are right, that I'm getting the right length of tenon, and that also the actual depth of cut to give me the width on both sides, on the two sets of sides, is correct. Both are checked using a digital vernier. As a final check, I do a cut on either side of the tenon, and then with a vernier I check the width of the intended tenon to ensure that it's the size that I want. In this case it'll be a bit over 20 mil. With those checks completed, the first cuts I do are to go right around the piece. This ensures that all the shoulders will be at the same point on the tenon. Using a series of cuts, we can now cut the main sides of the larger sides of the tenon. Of course, if you're doing many tenons at the same time, you do all of these sides, all the main sides of all tenons that are required, because to do the smaller sides of the tenon, the saw blade has to be adjusted in depth. Therefore you don't want to have to come back and redo them every time. So you do all the tenons that are the same, all the same sides, you do all one after the other. In this case I'm only doing one as a demonstration, so I don't need to worry about that. I'm just doing the one tenon. The adjustment to the depth of cut is the same process as was done for the long sides. In this case it has to be 10 millimeters depth of cut. A test cut is made again, same as was done before, to ensure that the saw has been set correctly. With the blade set, cuts are made on either side of the tenon, and the measurement of the length of the tenon, or correct, the width of the tenon is checked with a vernier. Now the smaller sides of the tenon can be cut in the same manner that the large ones were. The rough accuracy of the tenon can be checked by measuring it, just presenting it to the mortise. It should be a little bit bigger all the way around to allow trimming to an accurate size. The first step in the trimming is to use a saw to cut in the corners along the shoulder line. I use a Japanese Suzuki saw here. It's an old saw, but it still does the job. Now we need to trim the corners and make them circular so that they'll fit the mortise. The mortise was cut using a CNC mill, and therefore the corners are rounded in the mortise, and therefore these corners have to be rounded so that they'll fit into the mortise. The timber I'm using here is an Australian hardwood, and therefore it's not easy to trim even with a sharp knife. Most of the trimming work is done with a rasp. To complete work on the tenon, the shoulders are cut back next to the tenon itself. This is to ensure that the piece will fit firmly into the mortise. Having completed the tenon, it is now presented to the mortise and the fit tested. If a mallet has to be used to do the fit, that's fine. Means it is a good fit. In the next video I'll show how I made the sled that was used to cut this tenon. Please join me.